This video is a continuation of our discussion of normality, equivalence, and stoichiometry. A couple of introductory problems here having to do with equivalence and equivalent masses. The first one is, what is the mass of one equivalent of carbonic acid? Recognize that carbonic acid is an acid. It's got two hydrogens, but it's also what we find in soda. It's carbonated water. So we would first add up the molar mass of H2CO3, if you want to take a moment and do that. Two hydrogens, a carbon, and three oxygens. If you add up the masses of each of those, you'll find that it's 62 grams per mole. And if we want to find the mass of one equivalent, that would be the equivalent mass. Then the equivalent mass is simply taking the molar mass and dividing by the number of hydrogens. So you see there's two hydrogens. 62 grams per mole divided by the number of hydrogens is 31 grams per equivalent. So by dividing by the number of hydrogens, we change from moles to equivalents. And so that's all there is to finding the mass of an equivalent. You find the molar mass, you divide by the number of hydrogens. If it had been a base, what would we do differently? We would just divide by the number of hydroxides. All right, a slightly different problem. How many equivalents does 20 grams of sodium hydroxide represent? So here we go, here's a base. So if we're going to find out how many equivalents we have of that, we're going to need to know how much each equivalent's mass is. So again, add up the molar mass. If you add up one sodium, an oxygen, and a hydrogen, we'll find there's 40 grams per mole. We then count the number of hydroxides. The number of hydroxides is 1. That's not -1. That should have been an equal sign on there. So the number of hydroxides is 1. So we divide 40 grams per mole by 1, and we find that therefore it's 40 grams per equivalent. Let's get this out of the way there. All right, so 40 grams per equivalent, but we have 20 grams here. So if we have 20 grams and we want to know how many equivalents we have, we're going to set up like this. Here's our given, 20 grams. Our conversion factor is 1 equivalent is 40 grams. The answer is not on this slide, but if we take 20 grams, then the grams cancel out here. 20 divided by 40 will be 1/2 or 0.5, so our answer is 0.5 equivalents of sodium hydroxide. So there are a couple of problems on converting or finding the mass of an equivalent or the equivalent mass and then using that to find another problem.